Hello my dear friends, welcome to the YouTube channel Math Skill. In this session, let's try to prove m square minus n square whole square is equal to 16 times mn, wherein tan a plus sin a is equal to m and tan a minus sin a is equal to n. Now let us start the solution by noting down the problem. So here it is given that m is equal to tan a plus sin a and n is equal to tan a minus sin a, wherein we will have to prove that m square minus n square whole square is equal to 16 times n. Now let's start the solution. Let's note down the given data. So it is given that m is equal to tan a plus sin a. That is m is equal to tan a plus sin a. Also tan a minus sin a is equal to n. That is n is equal to tan a minus sin a. Now we will have to prove that m square minus n square whole square is equal to 16 times mn. In order to prove this, we will have to find out the terms m square and n square. We have m is equal to tan a plus sin a and n is equal to tan a minus sin a. So for this, let us square on both sides for both the equations to find out m square and n square. That is, let us square both the above equations to find m square and n square. So squaring the first equation, we would be getting m square is equal to tan a plus sin a whole square. Now this looks like a plus b whole square. So we know algebraic expression a plus b whole square is equal to a square plus b square plus 2ab. Here in formula, wherever there is a, we have tan a here, and wherever there is b, we have sin a here. Therefore, a is equal to tan a and b is equal to sin a. Let's apply the formula wherein we will get three terms here in RHS, that is m square is equal to tan square a plus sin square a plus 2 times tan a multiplied by sin a. Similarly, let's apply formula for n, that is n square is equal to tan a minus sin a whole square. This looks like a minus b whole square. We know that a minus b whole square is equal to a square plus b square minus 2ab. So here, wherever there is a, we have tan a here, and wherever there is b, we have sin a here. Therefore, n square is equal to tan square a plus sin square a minus n square is equal to tan square a plus sin square a minus 2 times tan a multiplied by sin a. In order to find or prove this, now let us find out LHS separately, that is m square minus n square whole square. We have already found out m square and n square, that is m square is equal to this value and n square is equal to this value. Now let's try to find out m square minus n square whole square. So for that, let's note down the LHS. Upon noting down LHS, that is m square minus n square whole square, for m square we have 3 terms, minus of n square we have 3 terms. So within the flower bracket, we would be having 6 terms. That is tan square a plus sin square a plus 2 times tan a sin a is for m square, and n square is consisting of 3 terms, tan square a plus sin square a minus 2 times tan a multiplied by sin a. This is for n square. So since there is whole square, so here also in RHS we have whole square. Now in order to simplify, let's open the common brackets. What we have in RHS, upon opening the brackets, the first 3 terms would remain as it is, whereas for the second 3 terms, the sign would change since it is getting multiplied by minus. Minus of tan square a is equal to minus tan square a. Minus into plus is minus sin square a. Minus into minus is plus 2 times tan a sin a. Now we see that here we have tan square a with plus sign and tan square a with minus sign. So, and also sin square a with plus sign and sin square a with minus sign. In next step, both the terms tan square and also sine square will get cancelled. That is plus tan square A minus tan square A is getting cancelled. Also plus sine square A and minus sine square A is also getting cancelled. We are left with two terms, 2 times tan A multiplied by sine A and 2 times tan A multiplied by sine A. That is 4 times tan A sine A whole square. So this looks like theory of indices formula A into B whole power m. That is A into B whole power m. That is within a bracket, if there are a number of terms getting multiplied and all the terms have a common exponent, then exponent is to be distributed to the individual terms. That is here 4 would be having an exponent of 2 in the next step. Similarly tan A would have an exponent 2 and also sine A. That is in next step we would be having m square minus n square whole square is equal to 16 tan square A multiplied by sine square A. This cannot be simplified further. Let us call this as equation 1. Now let us try to find out the value of the RHS, that is 16 times m into n. Let's note down the RHS 16 times m into n, which is equal to 16 multiplied by tan A plus sine A is m and tan A minus sine A is n. Therefore 16 times mn is equal to 16 times tan A plus sine A multiplied by tan A minus sine A. Now this looks like A plus B into A minus B. So we know algebraic expression, which is A plus B into A minus B is A square minus B square. So here wherever there is A in formula we have tan A, and wherever there is B we have sine A. Therefore A is equal to tan A and B is equal to sine A. Therefore in next step we would be having 16 as it is tan square A minus sine square A. Now let us try to simplify this. Let's take tan square A in terms of sine and cos. Therefore tan square A is equal to sine square A by cos square A. For tan square I have made a substitution, that is tan is equal to sine by cos. So therefore tan square A is sine square A by cos square A. Now let us take in the numerator we have sine square A from first term and sine square A for second term also. Let us take sine square A out, that is common. So is equal to 16 times sine square A is taken as common. Now I am left with 1 divided by cos square A as a first term minus 1. Let us take LCM. So LCM would be cos square A. So in numerator we would be getting 1 minus cos square A whole divided by cos square A. But we know that sine square A plus cos square A is equal to 1. But here we have 1 minus cos square A, that is which is obtained by transposing cos square A towards the RHS. We would get sine square A is equal to 1 minus cos square A. That we will now replace 1 minus cos square A with sine square A. Upon replacement, which would be 16 times sine square A into 1 minus cos square A is replaced by sine square A, and in denominator I have cos square A which is left as it is. Therefore sine square 16 times sine square A as it is. Sine by cos is again tan. Therefore sine square A by cos square A is tan square A. 16 times sine square A multiplied by tan square A. Or the same thing could also be rewritten as 16 times mn is equal to 16 tan square A multiplied by sine square A. This also cannot be simplified further. So let's call this as equation 2. Now earlier we had got m square minus n square whole square as 16 times tan square A sine square A. Now for RHS 16 mn, which is also we have got 16 times tan square A sine square A. Therefore comparing equation 1 and 2, we see that m square minus n square whole square is equal to 16 times m n. Hence proved. This completes the solution. Thanks for watching the video. Take care.